Mary, can you hear me now? Okay, guys. We're working with trigs here, page 1. Given that tan 2, all right, determine the general solution. Please, I'd like us to read the statement very well. It says, determine what? The general solutions are always generic. It's not one answer. That's when you bring in plus k, because we can use that to get more answers. For which the identity is undefined. Can we quickly define undefined? What is equal to 0? The denominator should be equal to what? 0. But please, I want to quickly warn you with something. Whenever you see 10 is very dangerous because it has two trig ratios. It has sine and it has what? Cos. Immediately you are working and you see 10. For example, that. Please understand that 90 is part of your solution instantly. Why? Tan 90 is an error. That's your asymptote. Before I even solve it, I already know 90 is one of my solutions. So that if your answer doesn't have a 90, you need to add it. I don't know if it makes sense. When you see 10, no matter what, once you see 10 alpha, please understand that alpha equals to what? 90 degrees. This is your, without even calculating, that would be a solution there. Because 10 alpha or 10 90 is what? Undefined. Make sense? It's the asymptote. So once you see 10, quickly, that's one of your solutions. But here, is it okay to just say our denominator should be equal to 0? Plus our 90 that we've said already. Okay, so what do we have? 2 sine squared alpha should be equal to what? Guys, that's 1 mark there when we're solving. What do we have? Can we find the square root of both sides? Sine squared alpha will be equal to what? 0. Oh, I've divided by 2, right? Now if I find the square root, what do I know? Sine alpha equals to 0. Make sense? How do you then solve this? Okay, so we are going to then work with our ref angle, right? Why am I using ref angle? There's the word general solution there. What is my ref angle? Ref angle will be equal to what? Is that fine with everybody? Now, what am I going to have? This will be what? 0. But which quadrant are we in? Instantly, and I want you to also learn your graphs. Instantly, I know my answers. I have 0, I have 180, I have 360. If you look at your graph, my x-intercepts, 0, 180, and 360. Those are where I'm going to get 0. Does that make sense? If you look at your graph. But anyway, can we walk through? My alpha will then be what? 0 plus k what? 360. Now, please look at this. Please, I want us to quickly get this. If we do this, this is the first quadrant, right? I just like to break it down. Some people say they want to combine. I just want to break it down. What is 0 plus k 360? K what? 360. Where k is an element of integers. Then I go to quadrant number what? 2. Because sign is what? Positive. Alpha will be what? 180 minus 0. 180 minus my ref. But what is my reference angle? 0. So 180 minus 0? 0. Plus k what? Sorry, 180. K 360. Now, do you notice that in this solution, 90 is not part of it? Make sense? And if you go back, look, take your calculator quickly. Press 2 tan 90 minus sine 2 times. Just anywhere you see alpha, put 90. Tell me your answer. Quickly. Anywhere you see alpha, please. I need us to work very fast today. Anywhere you see alpha, please put 90. I want to show you something. That's where I started this class from. You are not working on the left side. You are working on the equation. You are going to definitely get what? An error. And I want you to listen carefully to what I just said. You see there, if you put all of that, you are going to get what? An error. Do you know why? Because of the tan. Tan 90 itself, please, I'm going to repeat all of this. tan 90 itself is what? Doesn't exist. But if you leave your answer, check my answer. Do you notice my answer doesn't have 90? In case you don't understand what I mean, check this. You would not get 90 from here. And you would also not get 90 from here. But the examiner is waiting that, do you understand the importance, or do you understand your tan graph? Because it is tan alpha, automatically 90 is a part of my what? Solution. Are we okay? 90 is a part of the, and because it is a general solution, right? Since I'm talking about 10, k what? 180, k element of integers. It's 4 marks. 1, 2, 3, and you have your 4 there. Maximum of which one? Okay, that's easy. I'll do it for you now. Guys, are we okay? Please. So take note. When you see 10 in your equation and they say undefined, please immediately know that what? 90 is part of the solution, because tan 90 is undefined. We okay? All right. So that's very important. Let me quickly answer Leslie. Leslie was saying maximum, right? Look, guys, quickly understand that when we talk about maximum, let me quickly explain maximum and minimum. Let's do this together. Minimum and what? Maximum. For sine theta and cos theta, my minimum is -1 and the maximum is +1. Because our range then comes in like this. Minimum less than or equal to 1, y less than or equal to what? Maximum. Are we okay there? Range is written as minimum less than or equal to y, and then less than or equal to the maximum value. For 10, our minimum and maximum are actually -infinity, because you would see your graph going that way, right? Doesn't have an end. So what is the range of a tan graph? -infinity. No, not equal to. Please, is this making sense? I am now going to change a whole lot of things now. But this is the main thing. If I then start playing around to say, what is the maximum of sine 2 theta? Let's understand what this 2 is doing. This 2 is not changing the height or the bottom of your graph. It's only changing how wide your graph is. It says I have 2 graphs in the space of what? 360. It means my minimum range would still be what? -1 less than or equal to y less than or equal to what? 1. But if I come here and say 2 sine theta, watch what I'm going to do. What is the minimum of sine theta alone? It's -1. I'm going to say 2 into brackets. -1 less than y less than or equal to, can we simplify this now? Multiply the numbers only by 2. What will be your range? -2 less than y less than or equal to 1. Oh, sorry, 2. Guys, please, do you see where the 2 is? This one is just telling you that your graph is short or wide. But this 2 affects the amplitude. Your graph is now growing taller, which automatically affects what? The y values. Let's do another one here. Let's make it a bit complex. What is the range of this? 2 sine theta plus 1. Okay, let's do this. Can I have my 2 out? What is the range there? -1 less than or equal to y less than or equal to 1. Is that fine? Plus what? 1. Can we simplify this? -2 less than or equal to y less than or equal to what? 2. Now, plus what? 1. You're going to plus the ones in now. Because your graph is now what? Shifted, going where? Up. -2 plus 1. -1 less than or equal to y less than or equal to 3. So what's the minimum value? -1. What's your maximum value? 3. Same thing for cos. It's infinity. Even if they shift the graph up, it doesn't matter. Negative infinity plus 2 is still negative infinity because we don't even know what infinity is. I don't know if this makes sense, guys. So when you see minimum and maximum, just work like this. That other question required us to prove identity. I don't know if you were able to prove that identity. Okay, let's see. Which one? No, you will not get 90 there. Well, how would you get the 270? No, you can't just rock up 270. You've got to follow this. Your k is integers. 0, 1, -1, 2, -2, 3, So no matter what you do here, you're not going to get 90. So this examiner was waiting for you to lose this mark. And this mark came in because we are using what? 10. So we don't just add 270. Sine and cos is plus k what? 360. So if I were to list my answers here, what would it be? Let's list. I start by saying k is what? 0. 0 plus, what is 360 times 0? 0. Plus 0, 0. That's my first answer. K is now 1. 360 times 1, 360. Plus 0, 360. K is now -1. It becomes what? Negative what? 360. Do you see? I am moving in range of 360. If I were to continue, I'll get 720 and -720. If I come to this one, what would I get? When my k is what? 0. What will be my first answer? 180. When k is 1, I'll get 540. When k is -1, what would I get? Negative. Do you see? I'm still skipping what? 90. So the 90 came in. It's the knowledge of trigs because I'm using what? 10. So whenever you see 10 in your equation and they say it's undefined, know that the examiner wants to take 1 mark from you. And where's the mark? 90. Plus k what? 180. So if I were to list this, my 270 would fall in here now. Because when k is 1, what do I have? 90 plus 180. Type tan 270 on your calculator. You're going to get an error. Do you know where the 270 came from? From x equals to 90 plus k 180. That's where we're going to get all other asymptotes now. And because we don't have, do you know why they said general solution? They didn't give us a domain. There was no domain, right? That's why they said general what? So there are so many answers. So please just put it at the back of your mind. Once you see 10 and they mention undefined, 90 is part of your answer. 90 plus k what? 180. Can we quickly prove the identity? Let me see. I wanted to cut out the question. You guys said you got stuck here. How many of you tried this? Okay. You also got stuck. Okay, let's try. Let's try. Identify the identity in the identity. Change the identity into a simpler identity to prove the identity you are given. All you are doing is Okay, let's try. So, wait. What should we get? We should get sine over cos. Okay, let's try together. I haven't done it, so I'm hoping that I'll be able to prove all of you wrong, and I'll be very happy to do that. Rub it in your faces. Okay, let's start. I think we should do the right-hand side. Right-hand side. 2, what is 10? Sine alpha over, okay, let's do it together. I know you want to write, but let's do it together. All right. Minus, all right, 2 sine alpha cos alpha. Let's make it simple for us. Over 1. What's your question? Over what? 2 sine squared. Can I still leave that? 2 sine squared alpha. Let's leave it for.
So I learned something. Like we find a formula where it looks like that, and we manipulate it in a way that you see that. Like this. So if you have like.
Okay, don't just keep changing. No. Hold on first.
If you have 3 sine A plus A, then you know it's similar to 2 sine A. You know the identity.
Mm-hmm.
Right, then you change it or you divide by 3 or something. So with this one, there's an identity what plus 2A equals to 1 minus 2 sine squared.
Well, what I'm saying is, don't be in a haste to change.
Oh, okay.
That's why I'm not changing. Let's be in a haste to change. We don't know what's going to happen. Okay? Because you might change and then be off track now. So don't be in a haste. We'll change when we see the necessity to change to give us where we are going. All right? Okay, let's see. Can we deal with the top? It's fractions, right? We know how to. What do we do? DDD. 2 sine, that time will give us what? 2 sine alpha minus. Can we multiply across now again? What do you have? 2 sine alpha cos squared alpha. Is that fine with us? Over cos alpha. Let's check something here. Divided by what? 2 sine squared alpha. We would see where we're going. We don't know. But let's see. Oh, why did I write my alpha right on top there? 2 sine alpha cos squared alpha. I see that 2 sine alpha is common, right? Can we factorize? Let's see where we're going to get to. Equals to what? 2 sine alpha. What do we have? 1 minus cos squared alpha over cos alpha multiplied by 1 over what? 2 sine squared alpha. Are we together? We're not doing any magic so far. Let's see. Okay. These two, guys, we're multiplying, right? This sine alpha can also take away one of those. Let's simplify. We'll see. 1 minus cos squared alpha is what? Sine? Okay. Sine squared alpha over what? Cos alpha multiplied by what? Sine alpha. Now, this would go. What do I have? Sine alpha over cos alpha, and that gives my 10 what? Alpha. Baby, do you see what I'm saying? Don't let's be in a hurry to change. Guys, and that's our 5 marks there. So let's take it step by step. You understand? Don't be in a hurry. You'll get there. You know, one step. You see, okay, do I need to change? You see later if you need to change. Okay. You can. I can actually change my denominator and still walk through. Okay, you guys want me to change the denominator? All right, if I'm changing the denominator, what would I get? 2 sine squared alpha will be what? Cos 2 alpha. Guys, don't. Already you are getting another identity. Why when you are simplifying and changing, you are changing this is going to be 1 minus cos 2 alpha. Why are you going back to No. Come on. Guy, I see your mistake now. Guys, cos 2 alpha is what? 1 minus 2 sine squared alpha. Okay, if you change it, already you are getting into something else. So you don't change an identity into another identity that you require changing. I see where your mistake. This is what you guys are thinking. I think that's where you got it wrong. You are thinking of cos squared alpha. Yeah. And it's not.
I changed. I put like a bracket. I said, so you...
Test me. Please. Guys, there's a difference between this and this. When I want to, you see this 2 is the one causing the problem. If it was sine squared alpha, this, can you see that this is different from that?
Yeah, don't take that. So I said minus 2, open bracket.
Minus 2, open bracket.
1 minus cos squared alpha.
1 minus, yeah, okay, this is still fine. This is still fine. This is still fine. It will find a way of cancelling each other somewhere. That's as long as you are not bringing in cos 2 alpha. You don't change an identity into an identity that requires you to change that. No, we're creating a lot of problems. All right. So I hope it makes sense. I was scared when you said you guys did not get this. I was hoping that I'll get it to rub it in your face, and I did. Anyway, let's quickly run through. It's the heat. Okay, no problem. No problem. I think But sent me a question on trigs. Maybe I need to quickly do that before we just leave trigs. That question. Which question is that now? Tinamabob. I don't do Tinamabobs, please. I do maths.
And then the question maybe said,
Guys, we weren't supposed to do trigs today.
sounds like also, it's a bit of
Still, we did it yesterday.
All right, there's a question here that I tried to look at, and I think I want to quickly look at that. All right, please, I'm going to run on this one. In the diagram, okay, can I? Okay, guys, I can only do one question at a time. Okay. Where? Can you please hold on? There's something here that I want us to see. Someone just sent me this question some few minutes ago. So in the morning, but I only looked at it a few minutes ago. In the diagram below, the graph of f of x is sine x plus 1 is drawn from negative 90 to positive what? 270. Write down the range of f. Look at f. I think we did this just now. Y values. What's your range? What is your range? Range. Range. From what to what? Minimum, between minimum and maximum. What is our value here? 0, less than or equal to y, less than or equal to 2. And you don't even need the graph to get this. Why would I put 1? It is sine x plus 1. What is the range of sine x? Negative 1, less than or equal to y, less than or equal to 1. Now, plus what? 1. Can I plus my 1 in? Negative 1 plus 1, 0. Less than or equal to y. What is 1 plus 1? 2. And that's the same answer we're getting here. It's 2 marks that everyone must get now. Show that sine x plus 1 equals to cos 2x can be written as that. Interesting. The first thing I'm seeing here is that there's a 0 on that other side. So can we bring the cos 2x over? All right, and then we'll see what to do with it. So what do I have? Sine x plus 1 minus cos what? 2x equals to what? 0. Now, do you notice all my answer only has sign. That means that cos 2x must change to what? Sign. Or if you like, you can change it before bringing it over. It's still going to work. What do we have? Sine x plus 1 minus, brackets please, 1 minus 2 sine squared x equals to what? 0. Let's see. Can we expand together? What do we have? Sine x plus 1. Can we multiply in? Negative 1 plus 2 sine squared x equals to, the 1 and the 1 would go, right? What do we have left? Sine x plus 2 sine squared x equals to 0. What's common? All right, sine x. What do we have? 1 plus 2 sine x equals to 0. And we are done.
I can do it while I'm dying.
All right, guys. So we take it step by step and walk through. All right. Hence, otherwise, guys, I want to give you a moment. Please get me 7.3. General solution. Everybody. Everybody. Can we please do that general solution? I'll give you just 5 minutes. It's 4 marks. Hence or otherwise. Let's solve together. Hence or otherwise. Let's do 7.3. Let's do that general solution. I'll give you, you don't need more than, let's say, no, 7 minutes is just a lot. Please, I need answers quickly. Please, everybody, I need answers. This is where you would know whether you have now understood general solutions. Let's walk through. Once you are done, let me know. 4 minutes. And the exam, please take note of the word hence. Is that okay? Don't start from the beginning. Start from the where you ended. From there, it's now very easy. Okay, everyone, let's mark now. You've had a chance to check if you really do understand how to then deal with general what? Solutions. It's important that every time we get this, we should be able to get our answer. And this question actually has been done halfway. So what do we know? It's either sine x equals to 0 or 1 plus 2 sine x equals to 0. And on this side, what do we know? 2 sine x equals to negative 1. What is sine x equals to what? Negative half. Can we do the one on the left? The one on the left, what's our reference angle? Our reference angle is what? All right, which is equal to what? 0. So Q1, what do we know? We're solving for x. X equals to what? 0 plus K360. And that will be what? K360 and K being an element of integers. Q2, x equals to what? 180 minus 0, right? Plus what? K360. What's our answer? 180 plus K360, K being an element of integers. Can we go to the other one now? Okay, let me just rule this here. Now, if sine x equals to negative half, what is your reference angle? Okay, I don't do that. I just use my half. And what is that going to give me? 30. What is the negative telling me? It tells me I'm in Q2 and I'm in what? Q3. That's what we've been doing, baby. Because the negative tells me the quadrant. But you must know what you're doing after that. Q1, okay, I am now in Q2. What is my Q2? That's why I've been saying, please use one system and maintain that system also. 180 minus what? Reference angle. That's my Q2. What am I solving for? X equals to what? 180 minus, what's my reference angle? 30 plus K what? 360. What's your answer? 150 plus K what? 360. K being an element of integers. But I know I am also working in the third quadrant. Some people combine and say plus or minus. But I just want to stick to one method. Makes it easy for me. 180 plus what? Reference angle. What is my x? X equals to, what's my reference angle? Plus what? 30. And what do you have? Plus K what? 360. What do you have? 210. Plus K what? 360. K being an element of integers. Guys, there are other methods, but this is what I just choose. Some combine and bring in the plus or minus. But I just love it when I work in different quadrants. It helps me make it simple. And we are done there. Yes. Oh, sorry. I shouldn't have used Q. Sign is negative, right? Oh, thank you for seeing that. I should work in Q3 and Q4. I missed that. Q3 and Q4. Okay, can I just leave my Q3 fine? Is fine there, right? Can I just change this one? Okay. Thank you for seeing that. So what do I have? Q what? 4. What's our Q4? 360 minus what? The reference. So what do we have? X equals to 360 minus 30 plus K what? 360. What do we have? 330 plus K what? 360, where K is an element of integers. So if your answers are not that, thank you, Mary, just saw your message now. Are we okay with that? For me, it's very simple like that. I use my signs, and I know I'm working in Q3 and Q4. I maintain one system of operation. Can we sketch this graph? What are we sketching? Cos 2x. Can I please ask, what is your step? Yesterday we said cos 2x. I gave you a table, 90 over k. And what's my k? 2. And that gives me what? 45. And good enough? Our graph is already in steps of 45. So can we sketch together quickly? All right, so Calculators now. What do we have? Mode, table. Let's do that very, very fast. Very, very fast. From negative 90 to 270. And we're sketching what? Cos 2x. We're sketching cos 2x. I want to leave you with so much confidence that you're waiting for a graph. Are we okay? Cos 2x. I just want to make this big enough so that we can walk through. We're sketching cos 2x. Are we done with the calculators? Fumani, are we done? What are we waiting for? Fast. That thing should take less than 30 seconds to put in. All right, let's sketch now. All right, can we compare our answers on the calculator? Can I do that later? All right, can we compare our answers on the calculator? What is negative 90? What is negative 90? Negative 90. 0. Negative 45? Okay. What is negative 90? Negative 45? 0. 45? 90? 135? 180? 225? 270?
I have a question. How do you make it with one f of x, not f of x and g of x?
It doesn't matter. Just keep that one.
I did, but it came with the answers.
Baby, you've done something wrong. If I check now, you are going to now say, oh, you did that.
Okay, wait check again.
And remember, in this kind of things, you need perfection. There's no one to judge and compare your answers with tomorrow. It doesn't matter if it gives you f of x. Just continue. What did you type in? All right. This is cos what? 2x. And this is what? F of x.
So you can't put cos 2x right here, calculate. It's 2 cos x.
Baby, what are we doing? Cos 2x. Where's I did explain yesterday. Don't change. No, this is not being tired. Don't change the question. This and this, are they the same? Please, that's an error that would not be accepted. All right, let's answer the questions now. 7.5. Already, guys, there you have your, how many marks? 3 marks. 3 marks. Determine the values of x for which fx plus 30 equals to what? Gx plus 30 in the interval. Look, don't do anything other than what we've been doing. They are just simply telling us that the graph has been shifted. Where? 30 units to the left. And the thing is, it's not just only one graph, it's both graphs. Please ignore this for now. Ignore the 30. Can we find where f of x is equal to what? G of x. Ignore the plus. Let's go find where f of x is equal to what? G of x. When they are equal, what are we looking for? Where they are touching each other, right? And where is that? 0 and what? 180. So, my answer for this would be x equals to what? 0. All right? And x equals to what? 180. Now, let's go back to the question. We have shifted where? 30 units to the left. Now, you got 0. Move your answer 30 units to the left as well. So, what's your answer? So, the correct answer will be what? X equals to what? Negative what? 30 degrees. And x equals to what? 150 degrees. These are your answers now. So when you see the plus plus, ignore. There's another question like this that had plus 10 plus 10. Ignore the plus plus because both graphs have been shifted. So they were equal here. Now both graphs have moved what? 30 units to the left. So these points are also going to what? Move 30 units to the left. No. If they give you that, then you'll have to work under general solutions or replot the graphs. All right. Now look at 7.6. Consider the geometric series 1 plus 2 cos 2x plus 4 cos 2x cos squared 2x. Now somebody saying, now this is number patterns. Use the graph of G to determine the value or values of x in the interval 0 less than or x less than or equal to 90 for which the series will what? Converge. Let's start from there. What is the rule of convergence? Negative 1 less than r less than 1. What is our r? Let's go back to the r is what? T2 over T1. What is that? 2 cos 2x divided by 1. What is that? 2 cos 2x. Now, we had two graphs. What was f of x? Sine x plus 1. What was g of x? Cos what? 2x. Please, the examiner is trying to see, can we put this together? Let's see. What do we have? My rule of convergence is what? Negative 1 less than what? R less than 1. Make sense? What is my R? Negative 1 less than 2 cos 2x. I have not done any magic so far, right? We're still okay, everybody? You need to write this in terms of f of x or g of x. Which one am I using? G of x. Okay. Negative 1 less than 2. What is that? G of x. Are we okay there? Make sense? Now, can we divide everything by 2? What do we have? Negative half less than what? G of x less than 1. What are you going to do in the graph? You are going to look for where... Oh, 1 over 2. You are going to go to your graph now and find where you have negative half. Half. On which graph? G of x. Oh, they gave us a domain, right? Between 0 and 90. Mary, please, can you make your question clear? Where is x? I'm lost with that question. So we're looking at what? Negative half and what? Half. Let's do this. Let me try to do this. I hope this would make sense. My negative half is somewhere there. Right? And my positive half is somewhere there. Are we okay? But we are only looking at what? What's the domain? 0 and 90. Please, I'd like you to stay focused. I'm doing so many boxes just to make it very visible for us. I am working just right here between that and that. Make sense? So, between negative half and half. Where is it between negative half and half? Let's use this. You see my half? It's right there. Make sense? And negative half is right here. So this is where the examiner is referring to. Because anywhere up, this is half, right? And this is what? Where's my negative half? On the red. So we are looking for that range there. I don't know if it makes sense. Yes? I should go back to the question.
Oh, I see. Okay, makes sense. Okay, never mind.
I thought we were going to look for R and say R is X since they mentioned. Yes, Mary, now we are going back to look for X. See, all these questions are manipulation. Write them in terms of f of x or g of x. Then you go back to your graph. Guys, let's go through again. What did I say? R is T2 over what? T1. Do you see? We don't even know where we're going, but we're just following through. Since they said convergence, we know that, right? And that's my rule of so my job is to find what? R. R is T2 over T1, which gave us that. What's the rule of convergence? Negative 1 less than R less than 1. What is my R? Because I need to connect all of these things. But what is my R? 2 cos 2x. You see, they said use the graph of G. They even told us. Use the graph of G. And I know my G is what? Cos 2x. Can you see cos 2x there? What did I do? I replaced it with what? G. Do you see my x is now in? And there's a 2 here. So divide by 2, negative half, positive half. So remember, G of x refers to y values. Where are your y values between negative half and positive what? Half. So we went back to the graph and looked for that. Now, the question that you should be asking me right now is, we are dealing with x values. Our answer should be that x value there and that x value there, which we don't know. Because you see, the question says for which values of x. So we've done everything. This is where we are going to end. Our x value there and our x value. But it's not a trend smash. Let's do something together. Which graph is this? Cos 2x. All right. Y is equal to what? Cos what? 2x. What is my y value at this point? Because I want to get my x value. What is my y value? Half. Cos what? 2x. What do we do? Arc cos of what? Half will be equal to what? 2x. What is that? Yeah. All right. 60 equals to 2x. What is x? 30 degrees. It means that point is 30. To guess, to say 30, I need to show you how to get that. What about negative half? What would it be? Can you do negative? I want you to work this out. Please, everybody, let's do negative 30. Sorry? 60. Because it's 15 units, but I want you to do it. Let's do it together. So, guys, that's how you work it out, right? It's back to functions. We're just reinterpreting. Is it 60? Yes. So let me do it here, just for you. Y equals to what? Cos 2x. What is my y value? Negative what? Half equals to cos 2x. How do we get that? Is that fine with us? Negative half equals to what? No, 2x. That gives us what? 120. All right. 120 equals to what? 2x. What is x? 60. So already I have my values there. So what's my answer? What's my final answer? Between what? 30 and what? 60. So can we go write the final answer? I know it looks hectic, but it's just beautiful. What's my final answer? X must be between what? Negative 30 and what? 30. Sorry. Between 30 and what? 60. Positive 30 and 60. So if my x is in between that, it will converge. Guys, you just take it literally the way the examiner wrote it and manipulate. Is that okay? So whenever you see this question, write it in terms of what? F of x and g of x. Manipulate, and then get your x. Okay. All right, Butley, now it makes sense. Got it. She sent me that question. The way it looks, it's natural to throw everybody off because you're thinking, number patterns. And it's just maths, guys. So please, I hope you understood my interpretation. Just take it and connect it. Find a way of writing f of x and what? G of x. It's a lot of marks, and you need to show all of these calculations. So if you are able to show these calculations, you are going to at least get 3, even if you don't know how to read it on the graph. I hope it makes sense. This is why reading is important. You know what I just took? I took the word what? Converge. Wrote my convergence rule. Then I looked for R. Brought my G of X into R. And then looked for it on the graph without making any form of assumption. Are we okay? All right. Okay. I've got one question here. How many marks is this? 2 marks. It says, can I quickly write it down? We okay? All right. Use the identity. Use the identity. Let's walk through this. Cos alpha minus beta equals to what? Cos alpha, cos beta, plus what? Sine alpha. What are we supposed to prove? Derive the formula of what? Sine alpha plus what? Beta. Now, we already know what this answer would be. What is this answer supposed to be? Let me just write it down. It's supposed to be what? Sine alpha cos beta plus cos alpha. But we are supposed to prove it, right? Okay, let's try quickly. See. Since we are looking for alpha, sine alpha minus beta, and we don't know what it is, but they said we should use what? Cos alpha minus beta. Guys, can we change that cos into sine? Yes. So I'm starting from here, right? Yes. Let's walk through. Cos what? Alpha minus beta. How do we change this into sine, everybody? Because we must get sine. Sine what? 90 minus alpha minus beta. Is that fine with you? Okay. Let's see. Let's expand this. What are we going to have? Or let's simplify. Sine 90 minus alpha plus beta. Doesn't? Remember, we've changed that already. We've changed that already, right? Okay. Let's see something here. Now, we know that sine alpha, actually we should start from sine and change it to, no. Remember, I want to prove sine alpha minus beta. No, we're using the cos, right? To prove what? The sine. We should actually start from sine. Yeah. Watch this. I'll show you. Because right now, we are going to be stuck because we're supposed to use what? Cos. Okay. I started wrongly. Check this. We are looking for sine alpha plus beta, right? So we say sine alpha plus beta. Can we change it to cos? What will it be? Cos what? 90 minus alpha plus what? Beta. Are we okay with that, everybody? What will this give us? You see now, right? Cos 90 minus alpha. Is that fine? Minus what? Beta. Now, the trick here is this. This is alpha minus beta. This is then grouped. This becomes your alpha. Watch this. I group that, right? Anywhere I see alpha, what do I write? 90 minus alpha. So we're using that formula now. Can we use that formula? It is cos. What is my alpha? 90 minus alpha. Are you with me? All right. It's minus, so we just follow in. Cos what? Beta. Is that fine? Because it's minus there, it's now plus. Plus sine, what is this? 90 minus alpha. Sine what? Beta. Remember what we are solving. Sine alpha plus what? Beta. What is cos 90 minus alpha? It's sine. Sine alpha. What do we have? Cos beta. What is sine 90 minus alpha? It is cos alpha, right? Plus cos alpha. And what do we have? Sine beta. And we're there. All right? So, use this. The first thing is to write this, right? And write it in terms of cos. Cos 90 minus that. This is where the challenge is. For you to be able to manipulate and see that this is your alpha. Alpha minus beta. Cos that, cos beta, plus sine that, and sine beta. And then we're done. Yes? The same way. Only the sign changes. You're still going to use... You need to change this one first. Okay. Using this, we need to prove that what? Cos alpha plus beta. All right, check this. But they gave you cos alpha minus what? Look at this. I'm going to say this can be written as cos alpha minus negative beta. What is negative times negative? All right. So I'm still using alpha minus beta. Alpha minus beta. So what do we have? Using that, it is cos what? Alpha. Cos what? Negative beta, because that's now my beta. And that's my alpha. What do we have? If I'm using that formula, it is now what? Plus sine alpha. Sine what? Negative. All right. So what do we have? Cos. We know that cos negative beta is the same as what? Cos beta. What is sine negative beta? It's negative. Angle is negative. So negative times positive will give me what? Negative sine what? Alpha sine beta. They can give you sine, ask you to prove cos. You're going to work it out this way.
So basically, you just pick the one they want you to derive, and then you make that into the one that you...
Yeah, absolutely. So you start from what they want you to, and write it in terms of what you are given, and then just... Once you need to change from sine, do you notice that we didn't use 90 minus here? Why? Because they gave us cos, and we have to do what? Cos. But we used 90 when they gave us cos, and we had to do what? Sine. Every time you want to change, you bring in 90 minus. Are we okay, everybody? So please, you still have enough time to go through all of this. Okay. I know some of you have gone through this paper. Some of you have gone through this one. All right, quickly. Some of you have gone through this. I was just looking for things. I don't know whether or not. Did we all go through this? Okay, let's run through very fast. I need everyone's attention, please. I need everyone's attention. A survey was conducted among a number of learners who were whether you've done it before or not. The same cell phone company to establish the number of WhatsApp messages that were sent during a day. The results were summarized in the partially completed cumulative frequency graph. Do you know why I like this question? Give us A, B, C, D, E, F, G. It's not what we're used to. We're used to numbers, and then we sketch the graph. Now we have the graph, and we need to what? Deal with it. Okay. With the data, Write down the value of A. A tick mark on the horizontal axis of cumulative. We spoke about this yesterday. What is A called? the ground or the root. And where did we pick that from? From the table. We said it is the first class lower limit of the class what? Interval. It's one free mark that someone could lose if you're not paying attention to the root. What's our answer? Thank you. A is 40. Check your first mark there. A is 40. How many learners participated in the survey? Okay, I want to tell you something here. Good. This question actually has what I want. Examiner would give you this 500. Please, don't look at that. You look at the last dot. What is the last dot? 450. And we are done. We're moving. 450. That 500 was just because they were calibrating. So they do that, and a lot of learners just take that value and lose that one mark. Calculate the values of what? Q and R. I think this is why I actually chose this question. Guys, all of these dots we plotted yesterday, they are cumulative frequency, not frequency. They are adds on. Remember, we're adding on. So how would you get the frequencies? What is this? This is 0. What is this one? It's 10, 20, 30, 40, 50, right? So what is this? 20. All right. So what is 20? This is 20. I want us to write all of this. 20. What is this cumulative frequency here? 50. What is this one? 100. What is this? 200. What is that? 300. What is this? 390. 390. And this is what? 450. Can we now write the frequencies? We are just looking for the differences. The first one is 20 minus 0, which is what? 20. What's the next one? 30. What's the next one? 50. What's the next one? 100. What's the next? 100. 90. And what? 40. I think if we compare this with the table we should have 450, 60. 60. Okay. If we were to compare, I'm sure we would be getting the same answers as we have on the table. What was our first answer? Okay, let's see. It's 20, 30, 50, 100, right? 20, 30, 50, 100. 20, 30, 50, 100. We are done with Q and R. We are done with Q and R. Guys, quickly calculate the mean for me. Everybody, calculate the mean. Please, everybody, let's calculate the mean. This is also to allow us practice. Those of you at home, online, when you get your mean, please type it, throw it in. please get the mean quickly. Get the mean very fast. Anybody done online? What's your answer? 20. Monica, why are you getting 73,87? What are you doing wrong? What are we doing wrong? What are we doing wrong? Thank you, Mawande. Lovelies are here. Okay, we need to fix it, Monica. All right, we're going to look at it together now. And please, we don't want to get this wrong in an exam. Remember, guys, we are here right now and we can compare answers. Imagine you being in the exam alone and you cannot compare answers. So please, let's do it rightly. Okay, what do we need to do? What are our steps? Number one, we find what? The midpoint using your class what? Intervals. So please, everybody, let's get the midpoint. Let us get the midpoint. What's our first midpoint? Quickly, let's work. First midpoint? 60. What's next? 100. What's next? What's next? Next? What's next? And what's next? Guys, there's nothing wrong with, there's something wrong if we are now making a mistake here. What do we do? Okay, my frequency would be off, right? Remember we did this yesterday. Your frequency should be what? On. All right, so let me quickly put that on. And what do we have? 3 and 1. So mode what? Table. Is it start or table? 2. Statistics. What are we looking for? VAR. And we type that in. What do we have? 60 equals to 100 equals to 140. Please, guys, when you get back home today, make sure you redo this. You don't want to get this wrong in an exam. 180. 220. What do we have? 260. What do we have? 300 equals to. Then you go to your frequency. What's our frequency? 20. What do we have? 30. What do we have? 50. What do we have? 100. What do we have? Another 100. What's next? 90. And what? 60. Please, some of you would get wrong errors here, not paying attention to the things you are typing in. And I'm worried because there's no one to help you correct it. You are just left alone. So please and please, let's take time. Questions like this is what everyone should get correct. All right. Shift 1. 5. And what's our mean? Number 2, right? What's your answer? 205,78. Can we get our standard deviation quickly? I just want to check. Everybody, get me. You still have your values, right? Can we get standard deviation now quickly? (64,03). All right. So if I'm looking for standard deviation, just 1 second. I go back to my VAR. Monica, are you fine now? All right. Very much. We're not going to get all of that wrong. Can we move on? Please, I get worried when concepts like that are now wrong. What's our answer again? For the mean? 205, what? 78. Calculate the interquartile what? Range. How do we get in? There's something I need to do. IQR equals to what? Q3 minus Q1. Spoke yesterday about, okay. So, please understand the difference between IQR and SIQR. Let's take note. What is IQR? Q3 minus what? Q1. What is semi? It is IQR over what? 2. Because when we say semi, it's the half of it. So take note. How do we then get our QR? We did that with the position, right? Okay, let's get Q1. You see, when it comes to a group data, you can actually, it's always a small fraction of decimal, which can be ignored. What is this? 1 over what? 4 into bracket what? N plus 1. But the N plus 1 is because it's 0.25. What would this give us? What is our N? 450, right? Okay. I want to see what I'm saying. What would this give you? 1. 1. All right. This is why in this question there's always a margin in the memos for a range from this to this. But don't go and far values. What is Q3? Do the right thing. 3 over 4 into bracket what? N plus 1. What would this give you? Sorry, 3 over 4. And what would that give you? 3,25. All right. I know if this is 7.5, this should be 2.5. Now, guys, please check. Even if you ignore that and it gives you 450, what will this give you? It will give you 112. If you ignore that, it will give you what? 3. But these are not your values. These are positions. We need to go back to the graph and look for what? Those values. Can we go back to the graph together quickly? 112 and what? 3. All right. 112. Where would that be? That's 112. That's why I said you rather use N then because of that decimal, 0.75. What is this? 110, 120. You see, there's a range because it's difficult to get 1 there. Makes sense. All right. This is 110. What are we looking for again? All right. It should be between what? This one is 10, right? What's the next one? 120. So it's right. We all cannot get the same spot. Okay. So we go for somewhere in between there. Is that fine? That's why I said there is you can, Leslie, you were saying, how do you know? You cannot now pick a value here. Okay. Now, do you see this is coming right here, right? There. Please, we use a ruler. What was the next one? 338. Where would that be? 3, 10, 20, 30. Somewhere there.
So if you go on 40, it's fine.
Where are we ruling down? And remember what I told you yesterday. Please put those dotted lines on your graph.
So say example, you can say you 40, right? And then if you find the answer is off by 1 or 2,
Your answer cannot be off by a whole big value. That's what I'm saying. So once you are making mistakes, already answers will be wrong. Okay. What would this be? I think we don't we have all of this already? Okay, give me these values again. This one is 20. No, sorry. 40, right? Are you sure? Okay. 40. What is B? 80. What is C? 120. What is C? 160. Right? Upper limit, remember? What is my D? 200. What is my F? 240. And what is this? 240, right? 280 and what? 320. So what is this value? 160, 170, about 180, right? Okay, so this is my Q what? 1. That is 180. What about this one? Which one is my F again? It moved. Did it move? What are you talking about?
by 160, you say it's 180.
Oh, one.
It's 170.
No. Take note. Take note. Let's check something here. Let's be careful of the black lines and the dot. I think there's a problem here. Okay, that's 40, right? That would be what? 50. Okay, I see. My D is 160. Okay, 170. I was using the black line. One what? 170. Q1 is about 170. What about Q3? If this is, where's my F again? 240, 250, 255. Yeah, when I say 255,8, I'm going to ask how you measured that 0.8. All right. Some of you just, how do you get the modal class if you're only giving? Mary, we did that yesterday, right? Thank you, Monica. You just helped me there. It is the biggest gap. Okay, so what are we subtracting? 255 minus 170. Can we then do that? What is my IQR? 255 minus what? 170. What's your answer? 85. All right. Mary was asking how to get your modal class. What did we say yesterday? It is the biggest gap, right? That represents your modal. In this case, there are two modal classes. So should they ask? This is called a bimodal data. Bi means what? Two. So if they ask you for the modal class, you write the two classes. Don't combine. Say, I want to show that I know what I'm doing. No. Please don't combine. Just write the two. This class and that class. So in this case, which ones are my modal classes? Those. That's why we call it what? A bimodal. The biggest gap. Are we okay there? All right, let's answer this. The cell phone company new rule where you are not allowed to do what? Send more than 200 WhatsApp messages per day. If some of your phones will have to be taken. All right, left to me, I wouldn't do that. But responding to you, I will do that. Okay. The cell phone company wants to introduce what? A new rule. How to send what? 2 of messages per rule. Affected. Let me quickly explain this. I was doing something similar in one of the schools I was today. Check this. All right, check this. Please, I want us to listen to this. It's a quick summary I'm going to give you right now. Somebody just sent a message. All right, okay. Now, check this. If I have an ungrouped data, please, I want us to listen. I'm going to answer this question while working here. An ungrouped data. If a constant k, I gave you this, right? If a constant k is added to all the data entry, is it data or data? Whatever it is, it's DATA. Data entry. Data entries. I want us to quickly see what will happen. Old and new. So what we are saying, there's a question like that. I think it's Free State this year that asked something like that. Let's see. Old and new. My old mean is bar x, right? What will my new mean be? Remember, my new is old plus what? K. I've added k to every data entry there. What will be my new mean plus k? Don't recalculate. Any constant. If a constant k is added, a number. Okay, whatever they asked. If a constant is added, and it's very simple. Let's try this. Let's look at this. 1 plus 2 plus 3 plus 4 plus 5. What's your answer here? 15. What is the mean here? 15 over 5. What is that? 3. Now, what if I add 2 to every data? What happens? What will my new data be? I'm adding what? Plus 2, which is my k. To my new data be? Really? 1 plus 2, 3. Plus 4, plus 5, plus 6, plus what? 7. What's our answer? 3, 4, 6. That will give you 10, 15. That will give you 25. Now, what is mean? 25 over 5, which is what? Do you notice the difference? What's the difference? The difference was the 2 that we added. So you need to recap. That making my old mean was 3, and I added 2 to all the values. I can simply just add 2 to the mean to give me my new mean. Done. That's why we said our old mean is mean. The new mean is what? Plus k. Same thing will happen to Q1, Q2, and Q3. They will all change. Q1 plus k, Q2 plus k, and Q3 plus what? K. Let's see. What is the mean? What is the median here? 3. What is the median here? 5. Do you see it has increased by what? By 2. You don't need to recalculate. The ones that will remain the same are this. Your range will remain the same in both of them. What is 5 minus 1? 4. What is 7 minus 3? 4. It will remain the same. IQR will also remain what? The same. What? Deviation. Ones will what? Remain the same. Please take note. You don't have to recalculate again all the time. It will remain the same. Your range, because you are adding the same thing. Even if you subtract, you are subtracting the same thing. All right? So if a constant k is added or removed, we are on the same page. I'm going there right now. Which will help us answer. Standard what? Deviation. All right. For a wide spread data set versus a small spread, the standard deviation for the wide spread will always be greater than the standard deviation for the what? A small spread. All right? And why is this? Because deviation describes how far we are away from the mean value. All right. So the wider your data set, the bigger the what? Standard deviation. Let's just know that. Yes. Because you are looking, standard deviation actually, it's just that you guys, you're spoiled with calculators. We used to use tables to calculate standard deviation, where you say x minus mean, and then you square it over n. You know, it's just this generation full of microwave kind of. Right. Same thing with the variance, Monica. Same thing with the variance. You guys are just microwave generation. Even to make cake, there's microwave, there's instant cake. No, instant. For you to make cake, you must come with your flour. And now they mix it for you already. Okay, beginner wants to introduce instant rice. Microwave cake.
Where you make cake in a pot or in a microwave.
All right, anyway, so please, guys, can we answer this last question? And I'll just mention one more thing. I know we all know it. But what's this last answer here? It says they cannot send more than what? 200. Do you notice what were they sending before? 400 and what? 50. Guys, they were sending 450. Now they cannot send what? 200. Is that okay? So what has happened to the data set? It will decrease because it's now what? 200. The data range is now what? Smaller. Yes. It's a group of learners, right? Those who sent. Okay, wait. Those who sent 20 were between 40 and what? 80. 20 people, like that. So the total number of what sent is what? Oh yeah, the total number of messages sent is what? 320. Total number of learners is 450, right? But they're now saying they would not be able to send more than what? 200. So what are we doing? We are cutting the 320 into what? 200. What have we done? We have made it what? Smaller. If we make it smaller, what happens to the standard deviation? It will also what? Decrease. What is the reason? There is a smaller spread of data. We are done. 2 marks. It's going to become small. The answer. There's a smaller what? Spread of data. That's all. What? I hope you guys remember how to do one mean above standard deviation, lie inside and outside. Okay. I am going to, let's see. All right. I'm just going to create, I'm going to quickly create a set of numbers. Is that okay? And I want us to work as fast as possible here. 20, 23, 24, 28, 32, 44, 46, and 52. Please, may I ask everyone, quickly, I need answers. I want your mean and your standard deviation. Quickly, please, quickly, mean and standard deviation. Everybody, please, mean and standard what? Deviation. Let's calculate quickly. What is our mean? 33, comma? What's our standard deviation? All right. Now it says, how many, let's say, whatever it is, data set lie within. So I'm going to do both. One what? Standard deviation of the mean. Let's quickly do this. We find our boundaries, right?
Oh, is it different means 3 times below, above, and within, and then you say blah blah blah.
Mean plus standard what? Deviation. Can we quickly substitute here? What do you have? 33 minus 63 minus what? 11,31. What do we have again? 33, what? 63 plus 11,31. Do you want to give me answers?
The first one is 22.32, and the second one is
44,94. Now, how do we check? I'm just going to be writing in and out on those data. 20. 20 is out because it's not within. 23, in. 24, in. 28, 32, 44, 46, and 52. So how many lie outside one standard? Okay, no, okay, the question says lie within, right? How many lie within? 5. And if they say outside, what would it be? 3. But please take note of this. I want you to take note of that. Let me. Yeah, okay. Okay. All right, let's take it one step after the other. One standard deviation. Please take note. I want you to take note of that language. Otherwise, we just crumb things and do the same thing the same way all the time. One standard deviation means we multiply our standard deviation by 1. If the examiner had said 2 standard deviation, please, reading is important. You come here and multiply this by what? 2. So you'd say 33,61 minus 22,62. Because I have multiplied my standard deviation by 2. So don't just read that, oh, I'm used to this. We didn't. No, please look for that number there. One standard deviation means one standard what? One time standard. Because many a times we just do things based on what we've been doing, and the question is not asking you for that. So pay attention to what the examiner is asking you to do. All right, Tess asking me one lovely question here. How many data lie below? They will also tell you whether it's 1. Below one standard deviation. If I say below, what does it mean? Below what? So what do we do? When I say below, are we adding or subtracting? We're subtracting. So we are looking at x minus that, right? Yeah. So below is x minus that. And what did we get here? We got what? 22,32. So we count how many numbers are below that. We're done. Is that okay? Yes? This is 44,94. We have 44. We are comparing 44,94 is bigger than 44. It's inside. If it's 45, out there. All right. Guys, I want to run away from here, but it's important. I don't have a question on the board, but I'm just quickly going to do a summary of something right now. I'm going to do a summary of a scatter plot, and you have enough time, guys, to go through a scatter plot. I'm just going to summarize. Number 1, quickly, I'm summarizing this very fast. I don't want to use more than 5 minutes here. Scatter plot. You would need to put the values in the calculator, right? Put your values in the calculator. Basically, we are looking for calculators to find what? 5 things. I would need you to find 5 things. And the 5 things would be A, B, R bar X and Y bar. I think I don't want to jump that. I want us to. I want us to try. I have 125. I have 100. I have 568. And I have 62. I'll give you all of these values. 874. And I have what? 410. I have 321. And I have what? 54. What else do I have? 184. I'll give you the variables just now. 364. And then what? 51. And then 612 versus what? 76. This is the number of cars in the parking lot. And this is the number of customers. Is that okay? Number of customers versus the number of cars. Okay. So, a supermarket is located at a shopping center. The manager of the supermarket observed the number of cars parked in the parking lot between 7 and 8 over 7 days, and the number of outcomes inside the supermarket at the same time. The data is given in the table below. Now, which one is your X and which one is your Y?
X is the first one, right?
Your X is always what? The independent what? Variable. Right? Is it okay to say that the number of customers is dependent on the number of cars? Makes sense? If there are more cars? All right. So the key is to remember that this would be your X and that would be your Y. Can we then go to our calculator now, quickly? I want us to get A, B, R, X, and Y. I want you to do it without me saying anything for now. You have 2 minutes. Once you are done, please throw your answer in. Are we done? Some of us are done. All right. You want to give me your answers? What is A? Let's confirm with everyone. A is negative. What is B? X. What is B? What is your R? 0.6? What is bar X? 4? And what is bar Y? 1, 2? All right, let's see. Please, who is not getting this so that we can... I need to make sure everyone is on the same page. Biggie, do we have those answers? Kwanel, do we have them? Do we have them? Fumani? Can I see your calculator? You know I'm going to ask. All right, let's see. What do we do here? A calculator, right? You guys will help me with the values because that will cover mode. Sorry. We go to mode, right? What are we looking for? Statistics. Now, once you see that you are dealing with a plus bx, that's where we go. So we go to 2, right? Automatically, you have your x and y. What is the first x value? 125. All right, please. We need to be, when you type it in, make sure your eyes is on the screen as well. Because you might think you have pressed a value. It happens to me sometimes as well. I think I've pressed 5, but I've pressed 4. And once you do that, the whole thing becomes wrong. So keep your eyes there. 125. The next one. 568. What's the next one? 874. What's the next one? 321. What's the next one? 184. What's the next one? 364. What's the next one? 612 equals to. Then we go there. 100, 62, 410, 54, 122, 51. All right. We type all of that. What do we then say? AC. Statistics is that. Now, everything you are doing has to do with regression. So what do we go to here? 7. What is your A? A equals to negative 10,05. Please make sure you write those. What is your B? B is 0,31, right? Again, what are we looking for? Regression, which is what? R. 3 equals to 0,64. Please, I want you to take note here. These well learners also get it. Get it wrong. Please. This is not bar X. Please take note. That's not bar. Once you throw in that value, X and bar Y. This is a different statistics thing. It's a cap. Okay, so for me to get my mean, where do I need to go? I go to R. That's where we're working earlier on, right? 4. No, what did I press? Okay, sorry. Mine is 5, right? VAR. I'm looking. Can you see the signs are different now? It's no longer a cap, it's a bar. That's why we call it bar X. What's our 2? 435, what? 43. Beautiful. And then what do we have? VAR for number 5. What do we have? 5. Please get all of those. It's the mean. Yeah. That is the mean of the X values. And that's the mean of the Y values. X bar is always mean. So what's our equation? Y equals to what? A plus. Please, before you write that equation, start by writing what your A is. Negative 10,05. That gets a mark. Write what your B is. What's your B? 0,31. That gets a mark. Now what do? We substitute in. So what is our Y? Y equals to what? Negative 10,05 plus what? 0,31 what? X. No, I was asking for B. Even Fahima said, where did you get your X from? All right. Now, when your R is 0, right now everyone should have those tables. What is this? It's positive. R equals to 0.34. Can we comment? What is it? Before you go to average, it is positive. This is not strong. This is moderate.
Oh yeah, because it's not on one.
All right? Correlation. In one of my notes, I do have all of those values. Please just make sure you get those values again. All right? If any of these words is missing, you get it wrong. If you don't put positive, you get it wrong. If you say positive correlation, you get it wrong because the word moderate is missing. All right? So please, let's take note of how to write all of those. Now, quickly, I want to get through this. It's almost 6, and I still want to look at Euclidean geometry. Please, guys, what's important here now is how to sketch the graph. Please listen. How to draw the line of what? Regression. Drawing or regression line. Now, the regression line is also called the line of best what? Fit. It's also called an average line. Please take note. It is also called an average. So if you see any of these words, they mean the same thing. And because it's a line, it's a straight line. That's why we have y equals to mx plus what? C. Just 2 points that I need you to take note of, and I need to run from here. Number 1, the line must pass through, not just the y. 1, positive x or y what? Intercept. Please take note. The intercept could be positive x or positive what? Y, not negative. And number 2, it must pass through your bar x and your bar y. Please, very, very important. And all you need to do, guys, it's very simple. We've been doing maths. Check this equation. Y equals to negative 10. If you substitute 0 here, looking for your intercept, what would your answer be? Okay, I want us to write this equation down. Y equals to negative what? 10,05 plus? All right. What is our x-intercept? Y should be equal to what? 0. What do we say now? Y will be equal to, 0 would be equal to negative what? 10,05 plus what? 0,31 what? X. Can we find the can we find the value of x? What would it be? All right. What is our x? Over what? 0,31. What would that give us? 32,42. Please take note. Check this. I want to just show you something here. What if I find my y-intercept? Y will be equal to what? Negative 10,05 plus 0,310. What's my y-intercept? Negative. Please look at my first point. What does it say? The line must pass through what? The positive x or y intercept. Which intercept am I using? The x. Please take note. It must pass through what? The positive. Key here. So depending on your equation, that line must pass through the positive x or y what? Intercept. And what's the other point? It must pass through your average. Bar x or what? And bar y. Please. Very, very. And that's where the word average line came from. It must pass through your average point. Remember the word mean. What does it mean? Average. So when we say bar x, we're talking about what? The average what? Point. You will be told to sketch this graph. So sketch this line. Please, let's get it right. It's 3 marks. Is that okay? Finally on this, and I'm moving here, we use independent to get what? Dependent. What do I mean? We use x values to get what? Y. and not the other way round. Not the other way what? Round. Guys, we don't use y to get x in this equation. We use x to get what? Y. Please note. Life science or physics or whatnot, you cannot use the dependent to get the independent. We only use the independent to get the dependent.
When they ask, I think they asked once, how come, what is the reason when they ask?
I just mentioned we cannot use, just explain it like that. We cannot use what? The dependent to get what? The because independent is the variable that you are changing. You are not changing the dependent variable. You are only changing what? The dependent. Is that okay? So it's a rule in science that we cannot use the dependent to get the independent. So guys, you cannot substitute y to go and get x. It's wrong. They will always give you x and you need to get what? Y. But read the question very well. I think I once saw a question where they say, why can't you? Yeah. And that's just the reason. You cannot use the dependent to get what? Independent. All right. We okay, everybody? I need to run away from here. Please, you have enough time to watch this clip again. I think yesterday's clip and today's clip are just awesome. You have enough time. I saw this question, 6 marks, and I just felt, let's go through it together. All right. Someone once sent me this question, and I tried to work it out. Look at it. It says, the numerical value of cos 195 can be written in the form that, determined without the use of a calculator. This is very interesting. Once they say without a calculator, we need our special angles. Let's try something. Guys, we're dealing with special angles here. What are your special angles? 45, 30, 60. Okay, can you please do your maths? Which numbers do I add together to give me 195? Using special what? And what are my special angles again? 30, 45, 60. I can actually get 90 and 180 as well. Let's check. How do I get 195? Let's try to work. Let's try to walk around 2. Can we walk around 2? Okay, all right. You have 3. It's fine. Give me the 3.
90, 45, and 60.
Cos 195. You said is what? Cos 45 plus 60 plus 90. Are you sure this will give you 195? All right. Work with special. 270 is too far. Work with these numbers. Okay, you can work around that as well. But let's see. You'll get the same answer. Okay? But the main thing is we are playing around special angles. Remember, they expect us to know our special angles without the use of a calculator. All right. Now, check this. I can rewrite this value as... I can rewrite this as what? Cos 45 plus 60 plus 90. I don't know if what I've done makes sense. It's just put in bracket. What is 45 plus 60 in the bracket? 105. Plus 90. Because we want to, remember, we are all saying it should be 2 angles. So I've tried to write that what? 2 angles. So this becomes my alpha, and this becomes what? Beta. Is it making sense? Because our compound angles only has 2, so I group them now. Now, all right, let's see. Cos alpha, cos beta, right? What do we have? Cos, what's my alpha? 45 plus what? 60. Are you with me? Let's take it step by step. You remember your formula, right? Cos alpha, cos beta. What is my cos beta? Cos what? 90. Minus sine what? 45 plus what? 60. Are we there? Sine what? 90. What is cos 90? What is cos 90? 0. It means all of this just falls away. Because cos 90 is 0. Okay? So what do we have left? Negative. Hold on. What is sine 90? 1. Oh, that one. So we are left with what? Negative sine 45 plus what? 60. Does that make sense? Because the 90 just falls away. Okay? Please remember that the negative is just outside. Can we expand that? What do we have? Sine 45 cos 60. If it's a sine, the sign remains the same, right? Plus cos what? 45 sine 60. All right. Negative. What do we have? What is sine 45? Root 2 over 2. Root 2 over 2. What is cos 60? Half. Is that fine with us? Plus, what is cos 45? Root 2 over 2. What is sine 60? Root 3 over 2. We're just following the rule of maths. We've not broken any law. So, what would that give you? Negative. What do we have? Root 2 over 4. Root 2 over what? 4. Plus, what do we have? Root 2 over 4 times 3. Do you know why I'm saying root 2 over 4 times 3? I see that they factorize. I don't know if it makes sense. I must get b plus 1. So let's see. Root 2 over 4. I don't know if you see what I did. Multiplied by what? 3. I only multiplied 2 and 2. And I'm leaving my root 3. It's supposed to give me root 6. But I'm leaving that. Oh, sorry, root 3. So that I can factorize. Let's factorize. What are we going to get? What's common? Root 2 over 4. Negative root 2 over 4. What do I have? 1 plus root 3. If I want to write it like that in form of plus 1 at the back, negative what? Root 2 over 4. What do I have? Root 3 plus 1. Do you see your A? What is your A? Negative root 2 over 4. What is your B? Root 3. Can we please check cos 95 on a calculator? Let's check something. Cos 195 rather. All right, it's giving me that. If I expand that, that would be my answer. Yes.
So, I use the degree method for most.
Okay.
I've got the same answer.
Yeah, as long as you're not breaking any mathematical law. Okay.
So is it fine if my first step I go to cos 180 plus 15, then as I said it equals to negative cos 15. Then from there I use special angles to find angles that will give me 15 to 65 and 30.
Perfect. You're okay.
Oh, okay.
As long as you're not breaking any mathematical law, you're fine. Zahir, you said you have to put linear. It's already linear. There's no need for linear. All right, guys. So as long as, why is it wrong? Baby, can we expand this? What is negative 2 times? What is root 2 times root 3? Is root 6 over 4. What is root 2 times positive 1? It's negative there. Guys, no matter the biggie, you can get back home and try. It's going to work out. As long as we're not breaking. Okay, baby, can we expand this bracket? Baby, what is this? What is this? What is this negative times this positive? That's what I have. I don't know what you are pressing on your calculator. Okay, guys, you can do whatever you want. I am done. But you see, we're not breaking any mathematical rule. Just follow the principles and you get your answer. Okay, I have something to tell you on. This. This is now working with what? Euclidean geometry. Please, there's a very important concept I want us to quickly do here. Two main things that I want to quickly show you here. How to work with your ratios and how to deal with proportionality as a whole. I'm going to be very fast on this. In the diagram, Q is on BC. Don't mind the writings. I don't know who was writing all of this funny stuff. All right? In the diagram, Q is on BC, such BQ over... Please, guys, it is important and imperative that you use variables. Don't just write numbers. These are not lengths. They are ratios. If you don't write that, you are going to get confused somewhere. And there's an important concept that I want us to see. It says BQ over QC is what? 3. Where is my BQ? Here, right? And QC is there. Please, you see this person wrote 3 and 5. It's a problem. All right, 3, whichever letter you want to use, since you are BB, 3B, and what? 5B. There's no rule to say K or what. It's just a letter, right? Okay. What's next? BR over RA is 2:1. Where's my BR? There. Okay. And what? Okay. All right. 2 Leslie against 1 Leslie. All right. Now, are we okay, everybody? That's what we've done so far. Let's run. How are we looking? PC over what? RC. Just use different letters. That's all. You cannot write B on the bottom here and write B on top there. All right. RC over what? RP. I'm going to say something very important. PC. PC over RC. I'm going to say something very... Leave me alone. Something important on a system that you need to learn. Learners always find a struggle when it comes to... You see that second question. Please, if you get this now, you're going to move very swiftly in an exam. PC over RP. What is it? PC over what? RP. Oh, it's just here. PC and what? RP. Now, you need to find a triangle that has 2 parallel lines. And where's your triangle? There, right? Okay, lovely. So, can we consider triangle what? RTC. Is that triangle? What do we have? RC over PC over what? RP. PC over RP. What would that be equal to, by the way? Help. PC over what? RP. What would it be equal to? QC over TQ. Is that fine? I need you to listen here. QC over what? TQ. Do I know QC? Yes, 5B. My problem is what? TQ. Please, and you would see the importance of writing this in different variables. Are we okay there? TQ. If I can get TQ, then I'll be done. Right? Okay. But let's check. Is TQ in any triangle with parallel lines? Which triangle do you see? Oh, here. Is that fine? Is that what you see? That we now know that what? B over what? That's how you write it, right? Okay. Can we write prop theorem here first? Prop what? Theorem. Which lines are parallel? The first one we used. Okay, RT and PQ. Is that fine? We said our challenge was what? TQ. Now, can we get TQ from here? We can. Watch what I'm going to do here. What's my ratio here now? BR over what? RA will be equal to what? BT over what? TQ. Again, what do we have? Prop what? Theorem. It's again RT parallel to what? PQ. Is that fine with us? Do we know BR? What do we have? 2L. What's our RA? 1L equals to what? BT over what? RQ. What does that give us? It gives us that BT over RQ is equal to what? 2:1. Please, I want to say something here. What did I get? What? Oh, sorry, RA. Wait, BR over RA, right? Equals to what? BT over TQ. What did I say? I changed this one, right? TQ. I just made that mistake. BT over what? TQ. BT over. Please take note of this. Take note of this. I am now working on this side. Is that fine? If I'm working on this side, do you see that it's already a ratio of 3B? And I am saying that this is 2:1. It's already on the B side. Do you see 2 plus 1 would give me 3? It means this is what? 2B, and that is what? 1B. My problem earlier on was what? TQ. Is it sorted now? Oh, so I can go back to the top. What do I have? PC over what? RP, therefore. What's my QC? 5B over what? Over 1B. And what's my answer? 5. Are we okay there? So, start from what they give you and see what is missing, and go find what is missing, and we just work out our ratios. Are we okay there? The second one, I want to make life very easy. Should you find this in your exam, how you treat that? I'm going to create a second page quickly with the same question. Do you see we're working with area? Listen here. When I work with ratio of areas, use 2 triangles with common angle. Half AB sine C, where C is common. We are going to get this done now very fast. And let us struggle with this. Please look at my triangles. Let me clean this. Let me clean this quickly. If you just follow this, oops, I'm already cleaning my values. Okay, we remember, right? Just want to write it neatly. All right. Let's write the values again. What was this? 2. We said 2L, 1L, 2B, 1B, and 5B. Please, let's look at this. Look at this. I want us to do this in less than 5 minutes. Area of triangle what? ABC. Focus on your triangle. What triangle is this? BRC. Let's find ABC. A, B, and C. Make sense? All right. Let's find BRC. Where is B again? B, R, C. There's an angle that is common to both of them. There's an angle that is common. That's my first triangle. Right? And that's my second triangle. It's common. That's your trick now. That's where your answer lies. Are we together? Do you see how B is common there? That's where your answer what? Lies. You see this sine C? I'll be using that angle. So we have what? Area of triangle what? ABC over area of triangle what? BRC. We are using our trig. I have AB sine C. Where A and B are the sides that enclose the angle. Remember? So let's look at the red line. Let's look at the red line together, guys. The red triangle. I'm using that angle. Which sides are beside this angle? AB and BC. Does that make sense to you? Side, and the angle in between. Okay, so what would my formula be here? Half. What is that side? AB. What's the next side? BC. Sine what? B. The common what? Angle. It's the two sides. Whenever we do area rule, it is that side, and the angle in between. Now look at the blue triangle. Focus is still on angle what? B. Which sides am I talking about? Okay, you're going to give me that now. Half what? RB. Remember, I'm using the blue one now, right? RB. What's next? BC. Sine what? Check the mathematics there. What's happening? Sine B and sine B. Half and half. BC and BC. So what do we have? Area of triangle what? ABC over what? Area of triangle BRC will be equal to what? What is AB? 3L. All right. What is RB? 2L. What do you know about your L's? All right. So can I just throw that L out? So what do we have? 3 over 2. Look at the format of your answer. It says area of what? Triangle ABC. Can I multiply? What do I have? Area of triangle what? ABC equals to what? 3 over 2. I'm taking my area back there. What do I have? Area of triangle BRC. Is that what they ask us to prove? What is 3 over 2? 1,5. Once you see ratios of areas, go and use two triangles with a common what? So that sine what will cancel the sine what. And then you are left with numbers. Did it make sense? So it's just the system. Ratios of areas. Use two triangles with common what? Angles. Your aim is to be able to cancel out what? The angles. We okay, everybody? All right. Please and please and please. The 6 proofs must be done. 6 proofs. Tan chord. Angle at the center. Let's go to the grade 11s first. Tan chord. Angle at the center. What else? Line drawn from center. Opposite angles of a cyclic chord are supplementary. Then we bring in proportionality and similarity. Yeah, we mentioned it. Opposite angles of a cyclic chord are supplementary. Please, one of the 6 would be there in the exam. Already you are sitting with 6 today before tomorrow. 6 over 150. Yeah, I'm surprised when I mark and I somebody getting 3. Even the proof that you know. And the proofs, I did the proofs for you in short videos. Just watch them over and over again. All right?
plus 4. Does it all converge? And then plus 2 are similarity.
Similarity is only as a angle.
Similarity is angle, angle.
And then so the rest is from
All right. I don't know. Oh, can we look at this? Can we look at this question? Can we look at this question? I don't know how many of you were able to do this question. It's quite nice. It's quite nice. Without solving for x. Yeah, we're already doing Euclidean. All right, I did this yesterday with you guys, right? Okay, not everyone, with you guys. And the guys I'm looking at, they know what I'm talking to. All right, whatever, don't wow me. All right, let's just do it together. It's a very interesting concept here, very tricky as well. Solve it. Listen, whenever you don't know what to do, look at the answer. What's the answer? It will help you. I promise you. Can I show you how it will help you? Tan 2x. Okay, tan 2x. All right. I'm working from the answer now. What is tan 2x? Sine what? 2x over what? Cos what? 2x. What is sine 2x? 2 sine x cos x. All right. Cos 2x has so many identities, right? Do you notice that I already have cos 2x if I look at the question? What is cos 2x? I already have it. Nope. I already have cos 2x there.
Oh, I thought you were talking about the 2.
Thank you. All right. So I already have my cos 2x there. Already. Now the question is, so this is 1 minus what? 2 sine squared x. Is that fine with you? I already know where that cos 2x is coming from. Here's my problem. They have combined sine and cos. Where do I get that combination of sine and cos? It's here. Does that make sense to you? See, sine and cos. Is that fine? How am I going to, if I can bring sine x close to cos x, I'll be done. All right? So this is now me wanting to answer the question. I want to bring sine x and cos x. There's a 6 there. Can I replace my 6 with that? What is 6? 4 sine x. 4 to the power of what? Sine x. Baby, can we just hold on? I have what? 6 cos x equals to what? But what is 6? 4 to the power of what? Sine x. That's my 6, right? Now, cos x is an exponent. I already have my cos x. Equals to what? 8. What is 8? 32. 1 minus 2 sine squared x. 4 to the power sine x cos x equals to 8. But what is 8? We're just substituting things right now. Can I write both of them as the same base since I'm working with exponents? What do I have? 2 to the power of what? 2 sine. Check. I am here now. Equals to 2 to the power 5. What is 1 minus 2 sine squared x? Cos what? 2x. My bases are equal. What do I do? We equate the exponent. So what do I have? 2 sine x cos x equals to what? 5 cos 2x. What is 2 sine x cos x? Sine 2x equals to what? 5 cos 2x. Can I divide both sides by cos? What do I have? Sine 2x over cos 2x equals to 5. What is that? 10. Very lovely piece of question. When you're stuck, you saw what I did? Use the answer to always get what you want. So I looked at my answer and played around. Okay, if I can get that, I'll get that. And then we walk around. I'm not saying it's going to be a walk in the park, but we've got to be creative about it. Okay. And that is that. Let's have, all right. one question here on Euclidean. Please get one. In the diagram, cyclic quadrilateral P is drawn. Chord SR produced and chord PQ produced meter T. KPL is circle, all right? And we have all of that. UV is parallel to SQ and parallel to KL. Let S be X. What is our first question? Our first question says, find 5 angles with reasons that are equal to X. Some of you have done this, but let's give a chance to those that haven't. For those of you at home, I'm not sure if you have done this as well, but I'll give you. Alima, to save time. We should almost be done right now. Okay, guys, let's walk through this quickly. Okay, let's walk through. Guys, I'm not going to write reasons. please, here is the mistake you are likely to make. V1 is not equal to x because of time chord. The chord must be on the circumference. So our first answer, if that is x, this is what? X. What's your reason? 10 chord. Now, V1 will be equal to x. What's your reason? Corresponding what? Angles. This one will be equal to x. What's your reason? Alternate what? Angles. Now, this and that will be equal. 10 chord. And this is also what? Corresponding angles. Please, let's take note. From here, we got this one first, right? 1. Then we moved here. 2. We moved up. 3. From there, we moved here. 4. And number 5. In that order. Which other way? 4 and? From 2, where do you go to? Okay, wait. From 2, where else would you go? Because the first one is 1. We agree that the first one is 1. Okay, wait. The first one is 1. We agree. Number 2 is number 2, right? Okay, where do you go from there? You cannot go to 4. You cannot go to 4 from there. The only place you are going to is 3. All right? So this is the only order that we have. Okay, are we okay, everybody? All right. Can we move on? Yes? You're fine. Okay, Biggie, then Fahima. Yeah. It is. Yeah, but that's the next question. We're not there yet. Okay. We can say that if the question wants us to do that. Faima? I think so.
No, but then if you say alternate angles between P1 and S1.
Okay. Between P1 and? Oh, all right. Okay. P1 and S1. Okay, all right. I see that now. Okay. Whatever. At least we have the answer. Can we get to the second one? Prove that PQ equals to what? PS. Biggie, that question has now been answered. What's the reason? Yes. Side up. Okay, one second. All right. Mary, what are you saying? Okay, guys.
I wanted to ask that if you say that V2 is equals to X, because it's equals to Q1, and your reason is co-interior angles, is it right?
You said what? P?
V2 is equals to Q1.
V2.
X. Yes, sir. Is it right?
Why are we on V2 though? Okay, hold on. Let me just mark it. You said V2 is equal to what? Q1. No, they cannot be. That's co-interior. V2 is 180 minus X. That's not corresponding angles. Okay? Corresponding must be here. That's your F. On top there. But co-interior angles are not equal. They are supplementary. All right. You're welcome, Mary. Okay. Prove that KP is a tangent to the circle that passes through points PU. Now, look, to answer this question, I always say, if KP is a tangent, that's how I answer my question. All right? It says, prove that KP is a tangent through a circle that passes through what? PU and V. PU and V. Let's check. PU and V. PUV. Can I draw a circle there quickly? PUV. Or let's make it thinner so that we don't use all the space. PUV. All right, this circle is extremely big. Don't worry, I'll get it. All right, check that. I have a circle there. What are they saying we should prove? Prove that what? KP is a tangent. Let me just throw this question here. All right, prove that KP is a tangent. Check what I would say. I'm going to use highlighters now. KP. If KP is a tangent, then what? This angle should be equal to what? That angle. All right, so that's how you answer it. They said prove that it's a tangent. So you make an assumption to say it's a tangent. All right, and we have that. So this angle, and because they are now equal, what do we say? Yes, it is a tangent. But what would be your reason? When we use angles, then we say what? Converse. Is that fine with us? Okay, so let's answer this one quickly. B. What will be our answer for B? I'm going to say that what? P1 is equal to what? V1. And what's the reason? That has been what? Proven. Therefore, KP is a tangent. What is your reason? Converse of what? Tan chord. And we are done. Converse of what? Tan chord. And we are done. All right, let's look at the next question. Now, please, it is important that before we go today, you see, I want us to get, guys, please listen. Even if question C is challenging, you see A there must be something that everyone should get. But can we do 9.2.3? PU over PS equals to what? PV over RQ. PQ. PU over PS. Let's trace the lines quickly. PU over, they are talking about one side. Is equal to what? Let's confirm. PV over PQ. PV over, that's very straightforward. That is simply what? Prop what? Theorem. Because we have a triangle with two lines. So we're done there, right? What will be our reason there? Prop what? Theorem. Which lines are parallel? Which lines? UV and SQ. UV and what? SQ. Guys, please, question 9.2.4 is for every learner. I want us to be honest. Those 4 marks are for every what? Learner. And please, create a system. Follow the system I'm going to show you. And I've been showing you this system. When they ask you to prove similarity, number 1, make a list of the angles. What do you want to prove? PTS and what? RTQ. PTS and RTQ. Let's do this. PTS and RTQ. PTS and what? RT. Can we make a list of the angles? P. Where's T? T and S. Okay, let's check. Which angles am I looking at? P2, not just P. P2. Can we do it in order? T. S1 plus S2. Now, RTQ. Let's look at R. Where's R? R, T, and Q. R2, T, and Q3. Already, I'm done with one. It's T and T there. What's your reason? Common. It just make life very easy for you. Come on. You only need one more now. Now, let's go check. Let's go check and see if we can merge them together. Do you think we can merge P2 to R2? Let's see. I told you something earlier. I told you something when I taught you Euclidean. In order to answer your questions very well, please trace the source or describe what? The nature of the line. Check what I'm going to do. Look at R2. Okay, the source is actually from outside. But look at the nature of the line. Look at this line. It's next to R2, right? Oh, where does this line fall in? It falls into a cyclic quadrilateral. I'm already describing the nature of the line. You save time with this. You're not looking everywhere. Now, R2 is next to what? This line. And this line forms part of what? Oh, but do you notice this angle is outside there? So already I'm talking about what? Exterior. Which must be equal to what? Opposite. We are done. R2 is equal to what? What's your reason? I'm just going to put equal to now. Equal to. And what's your reason? Exterior angle is equal to what? Opposite interior. All you need to prove is how many? 2. What do you say for the third one? Third what? Angle. So what do we write? Triangle PTS is what? Similar to triangle what? RTQ. What's your reason? Angle, angle, angle. This is why I said this question is for everybody. 1, 2, 3, and 4. But if you do your own things, you're going to spend and waste time now. Just follow what I did. Make a list, match the angles. And all you are looking for is how many angles? 2 angles. The third one automatically just comes in by saying third angle. We are trying to save time. Okay. What's the next one? And every time you prove your similarity, please write your ratios. All right. Once similarity, what do we do? Write down your ratios. Can we write the ratio from this question quickly? What do we have? PT, talk to me, over RT equals to what? TS over what? TQ equals to what? PS over? What are we trying to prove? Check this. PT, let's mark it. Times RQ, can we mark it? PS, RT, we are done already. But what would be your reason for writing that? If I want to write this whole thing, I would first say PT over what? RT equals to what? PS over RQ. Triangle PTS is similar to what? Triangle RTQ. That's your reason there. That's why you can write that ratio. Can we cross multiply? PT RQ equals to what? PS RT. We're done. Make sense, everybody? Guys, it's all systems will always save your time. But if you want to start doing your own things your own way, you are going to spend time and not finish. But follow the system. It just automatically works. And while I'm here, please, this is not an advice for you. It's an order. Tomorrow when you start, you're starting at 8:50 and you are sitting with question 8. I've always said that. You run through that for 1 hour, 10 o'clock. If you don't finish Euclidean by 10, stop wherever you get to and move to the other papers, other sections. Please. You are likely to finish before 10 if you follow the system. There's no one that says you must start with question 1. The reason is you don't want to do Euclidean when you are now panicking because of time. You are going to see 1,000,000 lines when there are just 3. And start cussing out the examiner while you are still writing. Oh, this examiner is wicked. Maybe he fought with his wife before he set the paper. That's none of your business. So please, 8:50 to 10 o'clock, you are doing what? Euclidean. I promise you, if you follow the system, you are likely to finish before 10. 9:45 there about, you finish, and then you then decide, do I want to do stats? Do I want to do analytical or whatnot? Let's try to do this question. I've not done this question, but let's see. It says we should prove that what? PQ is the square root. All right. Check something here. This is me trying to think now. I've got just a few minutes, and I want to think of how to get through this last question. Let me just cut this last question. What would I do in an exam? I've been seeing this question, but this is the first time I'm actually sitting down with you. If I'm sitting, all right? I'm not avoiding it. I've been busy. Leslie, I am not as unbusy as you think I am. All right. Okay, let's see. Now, listen, I know we are all always scared. I don't even know what I'm going to do, but I'm just going to try to just see what I'm thinking. Hopefully we get it right. Look at this. I want to prove that. I think I'm working from the answer. I'll first get rid of the square root. That's what I'm thinking in my head. So I have a mind map right now. So if I get rid of the square, what do I have? PQ squared equals to what? PS, PT minus what? TS and RQ. All right. For me to get PQ, I'm thinking it must be PQ over PQ somewhere there. You remember we did that, right? Okay. I should be getting PQ, I don't know, something PQ. But by the way, look at the previous question. I saw something earlier on. We got something earlier on that says what? We got something earlier on that says what? PQ is equal to PS. Keep an eye on that thing there. All right. PQ is equal to PS. Let's keep an eye on that, because that would throw us off somewhere. All right. PQ is equal to what? PS. Wait. Do I have PS here? Will this work for me though? That's PS, right? All right. PS. Okay, but let's see. I know that my PQ is equal to what? PS. Let me just put that down somewhere. All right. PQ is equal to what? PS. Is that fine with us? Okay, it's something we got somewhere. Can we go find PS? Maybe we can get PS squared. Let's see. Is there a similar triangle that we can also work with? Which one did we prove earlier on? We had PTS and what? RTQ. Is there another? I see that in this triangle where we have these parallel lines, we also have similar triangles there. I don't know if we see that. Because this angle is equal to that angle is equal to that angle, and this angle is what? Common. Let's just write that out and see. What are we going to have? PUV, is that fine with you? Is similar to what? PSQ. All right, let's go see. PUV is similar to PSQ. Let's write that down. No. The whole similarity thing again. PUV is what? Similar to, do you remember what we wrote? PUV and PSQ. Okay, let's see. PSQ. Can we write the ratio out here? What do we write? PU over PS equals to what? UV over SQ, which is equal to what? PV over what? PQ. Oh, this is looking very, very interesting. Our focus is on PQ and what? PS. Okay, let's see. I don't know. What do we have? Because it's not giving us sufficient what? Information. What do we have? PV over what? PQ. Is that fine with you? All right. If we were to cross multiply, what are we going to get? PU, PQ equals to what? PV and PS. All right. This is looking more hectic than we're thinking. Can we quickly find these lines and find the relationship now? Because we've proven what we could prove. Let's quickly find this line and find the relationship. We have PS and what? PT. Let's see where those lines are. Where is P? What are the lines we're looking for? Okay, we're looking for PS and PT. Where is that? PS and PT. Lovely. PS and PT. Are we there? Okay. What else? TS and RQ. Where's TS? TS and RQ. Okay, the lines are just all over the place. All right. The first one was what? PS and what? PT. I see something. There's a minus there. So we've got to do some algebra connections. All right. PS, and these questions are not always very easy. That's why you cannot play around with all of those first few questions. You must get those correct. All right. I have PT, I have PV, and I have PQ. Let's go check something because I see that we're subtracting something there. So it might be a line that needs to be broken down into two. Does that make sense? All right. So this is where we are. Is there any line we have here? Let me see something. I have PT. Did I get any PT in my everything I've done so far?
Yeah, in the other triangle.
In the other triangle, we have PT.
Yeah.
Are you sure?
Yeah, in the ratio is really good.
Okay. Can we? Okay, hold on. I think I'm losing the other information that I have. What did we prove earlier on? Did I delete that thing? All right. PTS and what? RTQ. Okay, let's just write that down somewhere. PTS and what? RTQ. What's our ratio here? We use a white one. PT over what? RT equals to what? TS over what? TQ equals to PS over what? RQ. What line was I saying I was looking for? I was looking for that long line. PT. Okay, do we have PT here? There it is. What did we prove earlier on? Which one did we prove? No, that previous question. We had a ratio somewhere. Okay, we have PT. No, what was that? PT times RQ equals to what? RT. Okay, this was the previous question, right? All right. Remember, because I'm seeing a minus, I want to bring in something that will subtract. And here, okay, let's see. Here, what do we have? We have RT there. Oh, no, PT. PT is a long line. All right? So if I were to look at my PT, can I break it down into two lines that will help me? We are looking at what? PS, PT, TS, and RQ. PS, PT, PS is not there. PT, what else? TS and RQ. TS, even TS is not there. Oh, but wait, hold on. Hold on. Remember that PS is equal to what? PQ. So can I say that PT is equal, this long line, all right, is equal to what? PQ plus QT. Does that make sense? PT is equal to what? PQ plus QT. But I know my PQ is something as what? PS. Okay, what is PQ? It is PT minus QT, which is something as what? PS equals to what? PT minus QT. Are we okay there? Remember, there's a minus somewhere. I'm trying to find a minus. Are we on the same page? All right, let's see. So we said PQ equals to PT minus QT, or PS equals to what? PT minus QT. Okay, I have too many pages and I just keep going up and down. All right, this is where I am. Okay, I can see from here. I have PTRQ and what? RT and PS. Okay, do you see my PS there? There's a PS, right? Okay, please write this down for me. Remember what this is? Please write these two things down for me. PQ equals to PT minus QT. Write it down. So these questions will challenge you. Don't waste too much time on it. I'm doing it because I need to get it. In an exam, don't stay on it so long. You finish and come back and sit with it. All right? You have it for me, right? Okay. Let's come back here. What is my PT multiplied by RQ? What is PS? PT minus QT. Interesting. Okay. I'm making a mistake. This is RT. No, that's RT. Mistake. Okay. All right. So PT, RQ. Are we okay so far here? Remember where we are going. It looks very long. It looks very, very long. Yeah. It looks it's a thinking that we're not getting, and we need to. That's why I said you cannot afford to miss the other part. Missing the other part and still coming to find this one, now you are going to kill yourself. Is that okay? So those other ones, make sure we get them what? Correct. All right. This is where we are. I'm sure we would have gotten some marks so far.
Yeah, somewhere.
Somewhere. We're not getting 0. Okay? No, we need to be honest. All right? We're not getting 0. Okay? Just before you check the memo, I just need to do I need to do my own job first. All right, I've got PU, PQ, PV, and what? PS. Where did I get this one? Oh, from this ratio, right? SQ and UV. UV and SQ are kind of useless in this whole, they're kind of useless in this whole thing. But I had noticed, okay, wait, I have RQ, right? Where is TS going to come from? TS needs to come from somewhere. Okay, TS and what? TQ is also equal to what? PS and RQ. Can we walk around? The first time we used this, and this, right? Okay, if I use these two, TS over what? TQ equals to what? PS over RQ. Yeah. Okay, wait. TS and RQ is what? PS and TQ. Do we have this? PS and TQ? No. All right. PS is what? Minus QT. That's going to give me a QT squared. I need to get either PQ squared or PS squared. Oh, okay. I love this challenge here, though. I love the challenge. I love this challenge. TS and RQ. I have my RQ there. PT and QT. But I don't know. We need to find QR is not yet in this, and I'm worried with QR.
It looks like they use PSQ and QRP.
We've not spoken about QR at all in this whole thing we are doing.
Use triangle PSQ and triangle QRP. And then they give the ratio to you.
Yeah, let's try that. PSQ and QRT.
Did we prove that this? Did we write a ratio here? Because this should give me RQ. Did we write this one out? PTS and RTQ. Okay, let's see. PTS. No, I'm just trying to check. Do I have it here?
PTS and RT.
Okay, so I have my RQ. Oh, okay, I have my, okay, because I was looking for RQ all along. So I have it here, right? All right, that's what I was, oh, I also have it here. Oh, okay, beautiful. This is PS is equal to PQ, right? Please check for me. Do we have PQ, PT somewhere? PQ and PT. Or do we have TS and RQ? Okay. TS and RQ, right? Okay. TS and RQ, which is this, is equal to what? PS and TQ. That means if I can get PS and TQ here. Does that make sense? I'm playing around now. This is what you do when you are done with all your paper, though. Please don't waste time. Don't. All right. Okay. Do you notice PS is common here? If I factorize PS, what would I get? PS, what would I have? PT minus RQ. No, minus. Do you see what I'm doing? I said this and this are equal, right? Yeah. Now there's PS. Let's factorize. PS out. What do I have? PT minus TQ. Aha.
So if we use PTS and PS.
Okay, Bibi, just hold on. I don't know if it's what I'm trying to cook out here. All right. Remember, we got this, right? We said this is equal to this. Now I factorize PS. What do I have? PT minus TQ, which is what? PT minus TQ. All right. Okay, hold on. I think we might be onto something. Let me write this nicely as TQ so we can see it easily. We might be onto something. It's a mess, but it's a mess and we can fix it. All right. But I've got my... Wait. We said what? PT minus TQ. Why is it?
Because we subtract PS on top here.
PS? Where?
PS here. No, next line.
Yeah.
When you start where PS, you put PT minus TQ.
But now, why are we going to PV, PQ, and PU? Because it's not. We're going away now. We are somewhere close. Now we want to go away again.
No, but we said that PS is equal to
Okay. Okay. Just wait. So from the question, we are saying PQ squared equals to what? PS into bracket what? PT minus TQ. Is that fine? What is our PT minus TQ? We said is what? PS. So basically, if we can prove that PS squared equals to what? This is PS, right? Guys, hold on. I think I figured it out from the end now. Do you notice? Check something. Let's trace it back. If we can prove, can I create a new page for you? I think I found it, and it will be simpler now. But this is how we think, no one is the master of this story here. Check this. This is the original question, right? Is that fine? Somehow we're able to prove this. So PQ squared equals to what? PS, PT. We proved this, right? Which is there. PS and what? QT. Is that fine? What's common? PS. What do we have? PT minus QT. Do we agree? And we also proved that PS, remember what I asked you to give me? PS is what? PT minus QT. Check this. PS equals to what? That's PT. No. That's PS, right? Do we agree? What is this? PS squared. So if I can prove that PX squared is PS squared, I'll be done. Is that fine? Originally, that question we did, we had already proven that PQ is equal to what? PS. Now, our answer. PQ is equal to what? PS. What is it? Proven. Now, can we square both sides? PQ squared equals to what? PS squared. Does that make sense? I'm just using all my answers now. Can you see? Can I split it? All right. What would this be? PS multiplied by what? PS. This is still what? PQ. Are we on the same page? All right. Now, where did we get? Remember we said our PS is what? PT minus QT from the diagram. Do you remember how we got that from the diagram? All right. PS, but PS equals to PT minus what? QT. But PS equals to what? PT minus what? QT. Does that make sense? Can we replace it? PQ squared equals to what? PS into bracket PT minus what? QT. Is that making sense? Can we expand? PS PT minus PS QT. I think it's looking like where we are going. Where are we going? We are going to PSPT minus what? TS. Now, do you remember we were able to do this? From where? From this what? Ratio. I don't know if you see where that we have already arrived. You don't see that we have arrived. Can I copy this? I am done, guys. This is how we do. Yes. Check that. Are you okay with that? We are all okay with that similarity, right? Good. That this triangle is similar to what? This triangle. Is that fine with you? And we're able to get all of this. PT. Remember what we are looking for? We are looking for what? PS, QT. So from here, are we fine? Can I clean this? And bring this here. So can we cross multiply? What do we have? PS multiplied by QT equals to what? TS QR. Can I bring that here? What do I have? PS PT minus what? TS QR. And what is this? PQ what? Squared. What is PQ? It is the square root of PS PT minus TS QR. What are we supposed to prove? There. Biggie, you're not listening to me. No. You're not listening to me. What do you do in 10 minutes? Question 8. Then you continue. When it's 10, wherever you get to, what did I say you should do? Stop. Go and do other questions. I'm not expecting you to sit down on that for 30 minutes. No. So it's difficult, you leave it. When you are done with your paper, you come back and get some few marks there. Don't sit on a question that is difficult. All right? All right, we got it out of the way, and that makes me feel very good. Thanks, Shezi. I wasn't checking. All right. I will be uploading just now so that you can go through and you still have enough time to go through. All right. Good luck, everybody. We will talk on